Okay, welcome back to the pendulum experiment. We're going to be doing the data analysis section. So if you're up to this section, you should already have some data for your pendulum. Okay, and I'm going to take some data that I found because this is a good example of a non-perfect data. There's a couple of errors in here. One of which is they've measured in centimeters, not meters. It's not crucial here, but it is important when you input the data that is actually in meters. There's another mistake here. This one is actually critical. Okay, if you notice here that these are the values that they actually documented in the experiment, and they've carried an average and they've got that value wrong. Okay, so this is a common mistake I see with averaging. All right. What happened, I believe, and we'll check in a minute, is they've added up the three values, but they didn't compute it. They just divided the last value. I'll show you how that happens. If you go and so add up these values. Okay, so do 18.76 plus 44.42. Oops, I got that wrong. Delete that one. All right, that is 19. The third value is 19.25. Okay, then if you go and divide by 3, okay, you get the value that's about actually a little bit larger. They might have typed in a number wrong, or no, I think I typed them incorrect. But you see, it's too big. The problem is you need to either do that addition first and then divide by 3, or put a bracket here. You've got to make sure that all those values are added up before you divide by 3. So put a bracket around here. There, you got the right value now. That was 19. I should have actually looked a bit closely. All right, that is meant to be 19.2. So I'm going to type that in here. All right, so I'm fixing up your work. We never know who you are, but okay. Now I'm going to pause that, and I'm going to fix up the rest of these. Okay, so looking here, we've now fixed up the averages. We also need to fix up this other one here, because the single period is 1/10 of the average. So we need to take these values, divide by 10. Now that's pretty easy to do. All you got to do is move the decimal place. So 19.20 becomes 1.920. That is, okay, 1.666. Okay, 1.449. All right, 1.315, and excuse me, that is 1.104. Okay, so those are now fixed up. I don't want another row. Why am I doing that? All right. So the next thing you need to be doing, going down a little bit, and you need to download this file here. You can just right click and save as. So this is a Excel document, and it should help you out with the next section. What I'm going to do is I'm going to just go and make a little bit of space, and I already have one of these available. Okay, I'll use that one. I'll take that away as its own tab. Okay, what is going on? Sorry, I've lost my, okay, I don't want that. Let's pause for a second. Okay, so let's look at the recording again. All right, so I need to copy over my length. I'm going to put this in meters. So I'm actually going to type this in. It's just going to be faster. So 90 centimeters is 0.9. Now make sure you write that in without any units. If you write it with units, it's not going to work. Now I can show you. So if I do 0.9 meters, you see how it goes to the left? That's the Excel thinking that you're putting in words. If you just type the number, it moves to the right. It thinks it's a number. All right, that's important. Otherwise, it's not going to work. Okay. All right, so we type in the rest of them. All right, 0.46, 0.38, and 0.20. Okay. So then we're going to go single period. All right, so we've got 1.92. Actually, this one I can copy over. Just be careful when you do this. All right, so I might just go and do, let's have a look. Can I copy that over? Okay, I'll do Control C. And just to play it on the safe side, I'm going to right click, paste. What's going to happen? Now, it treats it like, that's interesting, treats it like it's a word. Let's take it out. Can I fix that? Yes, all right. Oh, it just has a little space at the end. I delete those, it will work. All right, so you just need to fix that, get rid of that little space. I don't know why it does that. All right. You see that it's not going to come up, but now I've done that. Okay, now I have a number here. All right, and I also have a graph. All right, you can copy in the graph in the section where it tells you to copy over the graph. All right, but right now I'm just going to deal with that number here. All right, so what you need to be doing with that number, there's a few other things you need to be doing. Okay, so I'm not going to fill out the rest of this. I've just fixed up their table. All right, but there's a few other tasks here. So basically, that number you've just got in the green there, that is your slope. Okay, so you've graphed t squared on your y-axis, you've graphed length on your x-axis, at least in terms of what's happening here, because the graph is actually, the y-axis is actually this calculation, that's the square of these numbers. All right, if you look at your graph, it's period squared versus pendulum length. All right, so then this is the slope of that line of best fit. Okay, so you need to write that number here. You can round it off to about 2 decimal places, and that should do. All right, now, if you rearrange the formula, if 4 times pi squared divided by g is the slope, you can rearrange that to solve for g. It is 4 times pi divided by your slope. I'm going to type it into the calculator as if I'm solving for that. All right, so my value is, okay, I'm going to do 4. Now, if you want, you can just type 3.142, or if you have pi in your calculator, you can do it a little bit more precisely. So I'm going to do 4 times pi divided by 3.63. I'm going to round to 3 decimal places. That would be an 8 there. All right, so I've done that, and I've got my slope. My value for g. My value for g is 10.85. That's a little bit higher than what you should be getting, but it's actually not that bad. No, we'll do that in a minute. So we'll put that somewhere. Okay, so I'm going to remember that, 10.85. Okay, now the last little calculation you do is actually working out the error. All right, so we're going to work out the error, so how far away we were from the actual value. The actual value should be about 9.8. So we're going to do that last calculation here, and then you've done all the calculations you need to do. All right, so 100 times by, okay, we do 10.85 divided by the actual value of 9.8, close bracket, divided by 9.8. So this will tell you by how many percentiles I'm off from the actual value. Okay, and it's about a 10.71% error, so that's not bad. 10% error. Okay, so that's how you go about doing the last few bits of this calculation. So I hope that helped. Okay, thank you for listening.